red paint. Splat. Let's talk about that. The first known examples of visual art were cave paintings created by Neanderthals using red ochre in 63,000 BCE. Red ochre is a clay pigment that gets its color from the reddish mineral hematite. Ochre naturally occurs in the rocks and soil of many environments where iron minerals have been deposited. The chemical formula for hematite is Fe2O3. The molecule is formed by 2 iron and 3 oxygen atoms. Hematite is formed when iron reacts with oxygen and moisture to produce iron 2 hydroxide, which further oxidizes and dehydrates to form hematite. This process of formation occurs in environments where iron is exposed to air and water.
To clarify, the color of red ochre is from oxygen giving electrons to the iron.
When light hits ochre, photons interact with the electrons of the iron oxide molecules. Electrons are subject to the quantization of energy. This means they are located at discrete energy levels. This concept can be better understood using the staircase analogy. Imagine that you are standing on a staircase. You can only stand on one step at a time, and it takes a certain amount of energy to move from one step to another. It is also impossible to stand at a height between the steps. Similarly, electrons can only occupy one energy level at a time and cannot exist between these energy levels. Moving between these energy levels requires the electron to gain or lose a specific amount of energy, such as absorbing or emitting photons. When light hits red ochre, the energy of the photons excites the electrons to a higher energy level. The human eye perceives red ochre as red due to the gap between the starting energy level of the electrons and the energy level when they are excited. This gap is equivalent to the energy of blue-green visible light. Ochre is seen as red because the light it reflects, red-orange visible light, is the complementary color of the light absorbed. Imagine a swing set on a playground. When you push the swing, it goes back and forth at a certain frequency. This natural back and forth motion is similar to how electrons in iron oxide behave. Just like the swing has a preferred back and forth motion, the electrons in iron oxide also have natural frequencies. Now, if you keep pushing the swing in time with its natural rhythm, it will swing higher and higher because you're adding energy exactly when the swing needs it. Similarly, when light hits iron oxide, if the light's frequency matches the natural frequency of the electrons absorb the light energy and get stronger. The color we see from iron oxide is a result of the frequencies that aren't absorbed. Ancient cave paintings are still able to be found today due to the insolubility of Fe2O3. This compound has a low Ksp value, which is the solid's ability to dissolve in water. Iron oxide does not dissolve easily because of oxygen's strong ionic bonds to the iron. These bonds are not easily broken, meaning the oxygen does not want to let go of the iron. Red ochre can be naturally found in most places around the globe. As a result, it has been used in various ways in different cultures throughout history. In ancient Egypt, they used red ochre for makeup during religious ceremonies because it symbolized the life-giving power of the sun. Many ancient cultures also put red ochre on their skin because it was a natural sun protectant and form of insect repellent.